On behalf of our group, I would like to welcome you today. For those of you who don't already know me, my name is Jenny. Our group will present our finding on chemical thermodynamic questions presentations. Content of this video: introduction, question 1, question 2, question 3. Introduction. Thermodynamic comes from thermo, heat, and dynamic, power. It comes from early effort to convert heat to power, heat engine. There are 4 laws of thermodynamics. Zero law. Two systems in equilibrium with a third system are in thermal equilibrium with each other. First law, conservation of energy. Energy can change forms, but it's either created or destroyed. Second law, entropy of an isolated system always increases. Third law, entropy of a system approaches a constant as temperature approaches absolute zero. Question 1. Discuss on various at least 3 temperature measuring devices. First, bimetal thermometer. The bimetal thermometer was created to be less accurate but more durable measurement device. There are still numerous industry applications where knowing the temperature of a fluid or device is desirable, but cost of an expensive probe and readout is not required. Example: machine building, heating technology, in air conditioning. Used to get a quick check to get an idea of the temperature, but do not need to know it down to the 10th of degree. Based on the idea that metal react to temperature change by expanding in different ways. 2 distinct metal strips with different thermal expansion coefficient make up a bimetal thermometer. Second device, thermistor. The term thermistor is a combination of the word thermal and resistor. A device known as a thermistor adjusts its electrical resistance in response to temperature. It's significantly more temperature dependent than standard resistor. There are 2 types of thermistor. 1. PTC, positive temperature coefficient. 2. NTC, negative temperature coefficient. Thermometers with a positive temperature coefficient exhibit more resistance at high temperature than thermometers with a negative temperature coefficient. Third, thermocouple. 2 wires of various metal are joined at the end to form the thermocouple. There are many different types of material for thermocouple. Each material pair has different characteristics of temperature range and voltage. A voltage is produced at the temperature-dependent junction of the 2 metals when it is heated or cooled. Thermocouple junction. First, grounded, the most frequent type of junction. When the sheet and the thermocouple components are joined to form one junction on the probe, have quick response time and can transmit heat easily. Second, undergrounded. When a thermocouple wires are joined but not connected to the sheets. Third, exposed. Wires are combined together and directly put into the system. Next, I will pass it to Jessica.
I will explain the operational principle of bimetal thermometer device. When it is heated, different metals expand at varying speeds. The movement of the strip of a thermometer, which is made of 2 strips of various metals, correspond to temperature and can be displayed along a scale. The advantages of bimetal thermometer is simple and robust design, less expensive than other thermometer, easy installation and maintenance. The disadvantage is it is require frequent calibration, not advised to use for high temperature and may not give accurate reading. The cost of the bimetal thermometer depends on the size. The bigger the thermometer, the more expensive it is. The 2-inch bimetal thermometer costs around 88 ringgit Malaysia to 400 ringgit Malaysia. 3-inch bimetal thermometer is 110 to 700 ringgit Malaysia. And the 5-inch bimetal thermometers is 200 ringgit Malaysia to 850 ringgit Malaysia. The range of applicability starts as low as negative 100 degree Fahrenheit, which is negative 70 degrees Celsius, and can have the maximum scale reading of 1000 degree Fahrenheit, which is 550 degrees Celsius. Next is the thermistor. The thermistor operates under the straightforward principle that a change in temperature causes a change in resistance. The thermistor begins self-heating its component as the ambient temperature changes. With relation to this change in temperature, its resistance value changes. The advantages of thermistor: it is less expensive, more sensitive than other sensors, fast response, and small in size. Meanwhile, the disadvantages is limited temperature range, resistant to temperature ratio correlation is non-linear, and inaccurate measurement may be obtained due to the self-heating effect, and it is fragile. The cost of the thermistor costs around $1 per piece, which is around 5 ringgit Malaysia. Thermistor only have a small temperature range that is within about 50 degrees Celsius of a base temperature, but they are quite accurate, varying from 0.05 degrees Celsius to 1.5 degrees Celsius. Most thermistor have a working temperature range of 0 degrees Celsius to 100 degrees Celsius. Next is thermocouple. A little voltage known as thermojunction voltage is produced at the junction of two different metals when they are linked. The input circuits of an electronic controller can measure variation in voltage as a result of temperature changes at the junction. It is possible to combine these two phenomena, and the resulting effect is referred to as the thermojunction effect or the Seebeck effect. The advantages of thermocouple is fast response time, low prices, and wide temperature changes. Meanwhile, the disadvantages is corrosion, it needs calibration, and interference can cause error. The cost of thermocouple is around 50 ringgit Malaysia, and the range of applicability is around negative 554 to 2003 degree Fahrenheit, which is negative 270 to 1260 degrees Celsius. The extension wire is around 32 to 392 degree Fahrenheit, which is equivalent to 0 to 200 degrees Celsius. Next, I will pass it to Nur Shafika Haifa.
Question 3. Which device would you recommend for use in the following cases? A. Monitoring the variation of temperature of a car engine block at several locations. The answer is infrared could be used to monitor the variation of temperature of a car engine block because it would allow you to easily see when the temperature is changing, since the color of light shown would change. B. Monitoring the temperature in the furnace of a power plant. The answer is a thermocouple can be used for temperature as high as 3100 degrees Fahrenheit. Thermocouples will respond faster to temperature changes than an RTD and are more durable, allowing use in high vibration and shock applications. Thermocouples are less stable than RTDs when exposed to moderate or high temperature conditions. RTDs and thermocouple are both used in power plant temperature measurement. Each has its advantages and disadvantages, with the application determining which sensing element is best suited. This is the list of reference, and thank you. That's all from us.